I guess we will start. So let me share my screen. Can you see my slides?
Yes, visible.
Okay, thank you. So, good evening. Today it is the fifth live session for course Basic Environmental Engineering Pollution and Abatement. And in this week, we will be discussing about air pollution control strategies. So, let's start with that. So, mainly, uh, air pollution occurs due to the presence of many gaseous pollutants or particulate matters made by dust or any such solid uh, combination. So in that case, what we need to do, we need to separate the particulates which are present in air. We need to separate the gaseous molecules as well. So here it is the list of various methods that are used for different types of pollutant. For example, if it has particulate matter, then we can use either gravity settling. This is electrostatic precipitator. Then there can be fabric filter or cyclone. For gaseous molecules, you can have absorption or adsorption. And for if you have particulate matter and gas both, then in that case, for mixture or like to separate both at a time, you can use scrubbers. Now, to start with each one of them, first is gravity settler. So, here, as the name suggests, you use the uh, intrinsic property of gravity under which the particles which are having more density, they will, like as compared to air, so they will tend to fall down. So what you do here, slurry here means you have gas plus particulate matter. So it is allowed to pass through the channel. It can be of this length. Now this length it has to travel, so it will have some horizontal component VH. Like the denotation or notation can be different, but there will be some horizontal component of velocity and there will be some vertical component of velocity, which is because of the gravitational force acting on the particles. So it will follow like a trajectory which is in this direction. So this will be the resultant direction in which it flows, and that is how the coarse particles will be settled first because more mass is there. So based on that, the force which is existing in the downward direction, it will be more, and hence the velocity will be more. So that is how you get first the coarser particles, then the intermediate, and later the finer particles. So you can say that different forces are acting on the particle, and based on that, it gets separated. Now, let's move forward. So another strategy is electrostatic precipitator. So for that, what you do, these are the plates. Okay, so in air, mostly the particles are of negative charge. So if you want to utilize that charge, what you do, if like, for example, negative charge will get attracted to positive charge. Okay, so here you put up plates which are connected to, these are positive like the positive potential is connected to these plates, which means the plates are also positive. So in that case, if you try to pass and these electrodes are negative. So in that case, if you try to pass the air through the like in between these plates, what will happen? The negative charged particle, they will get attracted towards the oppositely charged plate here, which is positive. Okay, so it will get collected over here. Okay, and when you remove the electric charge, they will get or they can be scrapped off the plates. That is how you collect the particles, and you can separate the particulate matter from the air so that you can have clean air. Now, another type of separator can be fabric filtration. So in that case, filters are like fabric is a kind of filter that will just be able to pass the air because of the like fabric will be porous. Okay, so it will not be able to allow particles because of their higher size. So the pores or the pore size of the fabric is decided or based on what application you have. So it will pass through that and particles will be collected. As you can see, it will not be able to um, pass through the fabric. Only clean gas will pass through this and it will get collected here. So these are series of fabrics which are used. Another is cyclone separator. So for cyclone separator, what you have is say, for example, this is the inlet of the contaminated air. So in that case, uh, it like centrifugal force will be acting on each and every particle because we provide rotational motion. So each particle will have opposite direction drag force acting and radial centrifugal force to oppose its radial motion. Centrifugal force will be acting. Okay, so in that case, due to the centrifugal force, um, the particle tend to move towards like away from the center. And here, as you go downwards, the particles tend to get collected, and there is a blower which will try to suck the air. So that is how particle will get connected here. Like it will go towards this side, and it will get collected at the bottom, like which is connected to a hooper. So next, coming to scrubbers. Now, scrubbers are nothing but it can be of spray scrubber, packed bed or plate scrubber. Then it can be Venturi scrubber as well. So, what do you mean by scrubber? Like you give a water spray or you use water because it is kind of wet scrubber. So, water and there will be counter clock or counter air motion. So counter motion, water will flow downwards and air will flow upwards. So air due to low density, it will uh, flow upwards and water will be flowing downwards. Now when you have vertical motion, particles will have retarded motion because of their higher density. Also, it will be trapped up by the water that you are spraying. So in that case, water will trap all the particles and it will fall downward to have a slurry or dirty water outlet. Now here there will be one more challenge. Like with air, air also can trap some amount of moisture or depending on what temperature is prevailing. Yeah, like you can say, if there is rainy season, then you will feel um, air to be more humid or there can be more moisture in air. So there will be certain gradient of moisture in air and in air. So that is why it can accumulate some amount of moisture also, and it can trap also some amount of water from the spray. So in that case, to eliminate that, you have this mist eliminator, and after that, uh, like here it will be moist air. So that moist air will pass through this mist eliminator to give you clean air. Now further, when you can collect this dirty water or slurry, and then you can have further sedimentation if you want to separate or collect the particles or so on. Uh, Now next is peg pad or plate type scrubber. So in that case, if you want to simultaneously remove gas, then you can particularly spray some solvent as well. But here in packed bed, you can have packing. Okay, so you are trying to increase the contact between air and the water that you are spraying. So in that case, the contact will be more, and that is how again there will be a mist eliminator here also. So in that case, better contact you can provide by packing some material inside. Also, you can provide hindrance to the motion and provide more contact by using plates so that air has retarded motion, and that is why that is how like you will have better contact between the better contact between water and your air, so the particles will get collected and it will flow downwards. Now venturi you try to change the path or change the velocity. Suppose this is how air is moving. So you try to reduce the area through which the air is flowing, and that is how you change the motion of particles. Now, after that, you insert a water stream that will collect all the particles, and later you can collect that slurry. You can have a cyclone separator. You can separate the particles and like hydroclone it will be, so you can use that. Another is absorption technique. So absorption technique, it can be kind of physical absorption or it can be chemical absorption. So physical absorption, it will usually just dissolve the gas, and chemical, you will have a partial reaction taking place. So for chemical absorption, one of the most common example is separation of CO2 from a mixture. So in that case, you can say that CO2 is it can reversibly react with amines or various amine solvents. Okay, so in that case, you can say that CO2 will react with these amines, and after reaction, CO2 will be separated from air. Now, this is how you can separate CO2 from air. Now, once to make the process more costly, user friendly, and more economical, what you do, you since the reaction is reversible, you try to regenerate the solvent so that it can be repeatably or it can be used for more number of cycles. So this will turn out to be more economical and more environment friendly. So you regenerate the solvent by heating it so that CO2 will be like you know that gas will be less soluble. Gases are less soluble at higher temperature, okay, in liquids. So, so you increase the temperature and you release the CO2, and that will be collected to have pure CO2. and again the solvent is recovered. Obviously, the regeneration capacity will not be 100%, but it is good like to have more and more regeneration efficiency. Now, again, there can be adsorption. So, where you do not have some chemical reaction, then you try to adsorb the particulate matter or you try to adsorb any gas onto the surface of it can be activated carbon, it can be silica, it can be alumina, so etc. For example, if you have if you would have seen your water bottle which is just unused, then there will be a packet and that packet contains silica. Okay, so silica is highly, it can highly absorb water. Now if air contains water, then it will give you some bad smell or foul smell. So in that case, what silica does, it absorbs some amount of moisture which is present. So silica is one of the um, absorbent for moisture, like if you want to control the moisture in air also. So this is how it works. Now another uh, strategy would be to like SOx is another pollutant which is present in air. So in that case, what you do, uh, you can use various metal oxides or you can use some amount for reaction to remove SOx from air, or you can use activated carbon to adsorb the sulfur oxides. So here this is the most commonly used method where you adsorb, okay, you pass the air through an adsorbent which is activated carbon here. So when air passes through that, sulfur dioxide will be adsorbed on it, and later there will be a regeneration section here. So now that sulfur dioxide can be used. Now it is, sorry, this will be air, like clean air. Now, if this activated carbon is containing sulfur dioxide, then you try to regenerate it by again heating it, because heating will initiate or accelerate desorption process. So heating accelerates desorption. So accelerates, or you can say favors also. Okay, so here desorption will occur, and so this is regeneration. So here you provide a heater. By heating the carbon, you can collect the SO2 because it will dissolve, and that SO2 can be used further for sulfuric acid production. So this is how this lift method works. Now for NOx, what you can do, you can try to control the NOx emission also. You can reduce the NOx emission by using lesser excess of air, because more amount of air you provide in excess, more will be the NO2 available, and in that case the chances of reaction between nitrogen and oxygen will increase, resulting in more NOx. So you try to reduce the air excess as much as you can. Then you can have multiple stage or two stage combustion. So in, or you can recirculate also the flue gas. So in that case, what you do, you are restricting the amount of oxygen that you are providing for combustion, and that is how NOx can further be controlled. Um, Further to treat NOx, like this is the strategy for release, control on release. So if once it is generated, what you can do, you can selectively or non-selectively do reduction of NOx. Uh, like if you remove oxygen, that is nothing but a reduction reaction. So for that, you provide a catalytic surface. So on catalytic surface, the reduction can happen, and you can have selective reduction where NO will get converted to, sorry, into, And you can have non-selective catalytic reduction where NO2 and NO both will be giving end product N2. Okay. Now air purifiers, there can be active and passive air purifiers like for example if you go or enter into a mall, there are air curtains. So they are nothing but they are trying to separate what outer atmospheric air is existing from the inner air. So you prevent more and more contamination. Uh, in active air purification, what you do, you try to provide charge, like which is not so commonly used, and passive you collect as it is. Okay, so now I will forward move towards the assignment. Yeah, so first question is VOCs are a large group of chemicals that are found in many products we use to build and maintain our homes, such as perfume, paints, hairspray, cleaning agents. The full form of VOC is dash.
Volatile organic compounds.
Yeah, so these are nothing but volatile organic compounds that can immediately evaporate, like if it comes, or they are low boiling. So, for example, acetone. Acetone has very low boiling point of around 56, and they are used in nail paint removal. So, next question is which of the equipment is not used for the removal of particulates from the gas?
Ball mill.
Yeah, so ball mill is the correct answer. Yeah, it is easy to eliminate from this. Can you tell me what is the function of ball mill?
It is basically used for size reduction.
Yeah, correct. So ball mill is a size reduction equipment. Okay. It will be used for crushing the particles. Someone has raised the hand. Okay. So next question is identify the missing force in the following depiction of force balance on settling particle.
Kinetic force.
No, it will be buoyancy force. Okay, let me explain this. If this is the particle, and here, let's say it is any fluid, okay, it can be air, it can be any particular gas, or it can be any liquid. So, fluid can be gas or liquid, okay. So, now this particle is present in this much space of that fluid, which means that it has replaced, like let's say the particle is having volume Vp. Okay, so it means that similar amount or equal amount of volume of that fluid has been displaced by this particle. Okay, so in that case, for displacement, there will be some force required to displace that. So in that case, you can say that it also requires energy, so it retards. Like to displace anything, you need to overcome some forces, and that is why there will be some amount of buoyancy force, buoyancy force acting in the direction which is opposite to the motion of particles. So here if it is moving in downward direction under the influence of gravitational force, then in that case buoyancy force will be acting in opposite direction. Okay, so here buoyancy force is the correct answer, and drag force, it will also be acting in the opposite direction of motion, which is nothing but the characteristics to like retard the motion of any particle in any streamlined flow. I hope it is clear.
Yeah,
Okay, so next is calculate the overall collector efficiency of gravity settler for the dust sample. Data is given in the following table. So, yeah, weight here is given per like 100 gram, which means that the total or summation here of this column will be 100 grams. So you are taking 100 gram of dust and you are doing the size check. So this is the size distribution you are having, and this is the corresponding efficiency for collection. So for overall efficiency, what do you need to do? Can you tell me formula? Like it is very basic. Okay, so let me tell you. So just for simplicity, for example, if out of 100 grams, if you are dust having size less than 5 units is having 2 grams, and out of 2 grams only 1% is getting able to be separated. Okay, so out of 2, if 1% is getting separated, Um, then for efficiency, what you do, you try to calculate out of 100. Okay, so out of 100, what will be the amount that will get separated? So what you do, uh, you first calculate overall efficiency. So for that, you just need to take the weighted average. So summation of eta I, like which is the fractional efficiency for any particular distribution, into the weight fraction I. Okay. So now how, because this will give you like what fraction of weight is present in that distribution and corresponding efficiency. So this is how you take the average. This is nothing but weighted average. So weight fraction you can get by finding weight of any species divided by total weight. Okay. So if we simplify this, then summation of eta I into small wi, like which is nothing but the weight divided by total weight. So here you can take total weight common because it will be denominator in each and every case. So 1 by total weight, which is nothing but 100, into summation of eta into wi. So eta is this, and weight uh, in that corresponding size distribution is this much. So for that, what you will do, 2 into 1. So 1 is the eta I, wi is 2. So now you do for each and every case 7 each for 5 to 10 size distribution, you have eta I to be 7 and weight is obtained as 3. Then for 10 to 15, you have 20% efficiency and 4 gram weight. So you do for all the rows till 5 into 100. Okay, so you can see here that as you increase the size, the efficiency of removal is increasing because the size is increasing. So more the size, better will be the efficiency for removal. So you simplify this and calculate this and tell me the answer. Here you are using percentage as the unit for efficiency. So whatever answer you will get, that will be in percentage. So calculate and tell me. Are you able to follow me?
Yeah.
Will we- Okay, so answer should come to be 80.9 percentage. Calculate and tell me whether you are getting that answer or not.
Yeah. 80.9.
Is everyone getting? Okay, so let's move forward. Typically, value of air to cloth ratio for dust loading for fabric filters is like this is a theoretical value that you follow. So this is the most probable range, which is nothing but 1.5 to 3.5. MSW based power plant is emitting 55,000 meter cube per hour flue gas. It is proposed to install an ESP with collection efficiency of 96.8%. Now calculate the total area of collection electrodes, and the drift velocity here is given as 0.13 meter per second. So for this is the formula based on which you can calculate the area. So here AC is the area. Other than that, what you require is eta C. Eta C is the efficiency of this ESP, which is nothing but given as
96.8.
96.8 percentage. That is equal to 0.968. Okay. Then you are need VPM. So this is nothing but drift velocity. Okay. So drift velocity is given to you as 0.13 meter per
0.13.
second, and then you require Q. So Q is given as 55,000 meter cube per hour. So now this is unitless, this to have unit. Okay, so here meter is common, so you will get answer in meter square, but the time unit is different, which is hour here and second here. So you need to convert one to the another. So let's convert hour to seconds. So 55,000 meter cube per 1 hour has 60 minutes, and 60 minutes, like 1 minute has 60 seconds. So that is nothing but 3600 seconds. So this many seconds. So now if you put up all the values, then 0.968 equals to 1 minus exponential of minus VPM is 0.13 into AC divided by 55,000. Now this is divided by 3600, which will go in the numerator, which will be into 3600. So if you do the simplification, um, tell me what do you get? So 1 minus here, it will come out as exponential of minus 0.0085. So if you simplify this further, here there will be AC also. Sorry. 1 minus 0.968, which is 0.032. Now, for this, to remove the exponential, you need to take ln on both the sides. So if you take that, minus 0.0085 AC will come out to be minus 3.44. So minus minus will cancel out, and AC will be 404.9.
30.
Yeah, so More or less it is same. So D is the correct answer. Yeah, I hope it is clear.
Yeah.
Okay, so let's move forward. Fabric filter, the hints correlation could be given as that this. Here, psi is dash. So it is nothing but Stokes impaction parameter, because here you are using impact as the um, uh, method by which there will be separation. So this factor will give you what will be the impact or the parameter that is a measure for that. So now moving forward, which of the following option appropriately connects the adsorbent with the impurity type? So first is silica gel. So silica gel is used for adsorption of what? So yeah, it can separate ethane, propane, butane, and heavier hydrocarbons. Then activated carbon, it can separate methane and carbon dioxide. Then you can have molecular sieve, uh, which can separate methane, carbon monoxide, and nitrogen. And activated alumina can separate water. Yeah, this is given in your slides also, given by professor. Can look into that. Next question is, what is the aspect ratio for five field electrostatic precipitator having collection plate height 30 feet and collection plate length 9 feet. So width here given is given to you as 50 feet, um, which is normal to the gas flow. So can say that height is 30 feet. The length of the plate, like this length, is given to you as 9 feet, and the width is given to you because it is normal between two plates. Sorry, it is 50 feet. Okay. So here in this direction, the gas is moving like between the two plates. So what distance it will travel? It will be 9 feet, and the height that will be covered is 30 feet. So the aspect ratio will be defined based on these two parameters, 9 feet and 30 feet. And you have such five um, um, annular spaces, like five separations are there, or five spaces are there from which air passes. So you can say there are six plates. So in that case, five field means 5 into 9 will be the total amount of gas that will pass through. So aspect ratio is nothing but length per unit height. So here the total length that will be covered by, if you consider all, so it will be nothing but 5 times 9, okay, divided by height, which is 30. So it will be 45 by 30, which will come out to be 1.5. Next question. Collection efficiency of scrubber is given by dash. So psi here is, as it was mentioned, impaction parameter, and K is empirical factor. So these are nothing but kind of constants which have their own significance. Okay. So that's it from my side today. If you have any doubts further, you can tell me.
Uh, in the previous question, Question.
Ninth?
Yeah.
Huh.
Why we had taken the length as 5 times of 9?
Yeah, because you can say that sorry, you can say that there will be five field means there will be five sections through which it will be flowing. So
Okay, 5 plates.
huh.
Yeah. Okay. Got it.
Do you have any other doubt? Okay, so if not, I will end this meeting. Next week we will be meeting on regular class on Tuesday at 7 o'clock. Thank you for joining.
Yeah. Thank you.